Tonight I'm going to talk about IoT. I'm going to talk about how Appdynamics has extended our core APM, application performance management solution, to add some functionality around specifically IoT. I'm going to start with some slideware. It's about 10 slides, so hang on. I got to set the stage, and then I'm going to jump into a demo of that. A lot of things have to go right for this demo to go well, so everybody cross your fingers and toes. So where are we now with IoT? IoT, Internet of Things, has become a bit of a buzzword for a long time, but people are now starting to figure out how to quantify it in terms of functionality and how it can impact their own businesses. How many of you are using IoT in your business to some extent? 1, 2, 3. How many of you are thinking about using IoT? No. So why are you here today? Well, I'll show you some fun stuff. What?
We find you a little missing.
All right, exactly. So hopefully this sparks the creative juices and you get excited about it. But look, a lot of people are using IoT. So this graph shows that by the time Google Glasses were invented in 2013, there are already 11 billion IoT devices on the planet. So and then nowadays, that was only after IoT was brought to life a few years beforehand. So you can see the rate of adoption and proliferation in the market is exponential beyond all things. Everything you can call anything an IoT device at this point. And what's really phenomenal is about less than a percentage of devices that conventionally use IoT business logic, business intelligence, or to drive analytics in their business are actually producing those kind of metrics. People are using them to serve a function, but they're not deriving business value out of that. So I'm going to show tonight how you could potentially think about how you can connect those dots using Appdynamics. It's nice for us. I'm a sales engineer. I kind of wear both the hats. The engineer, the sales side of me, likes this figure that 30% is going to increase, because that means people are going to spend money on figuring out and unlocking the whole IoT box and deriving value for the business. So what is an IoT device? It could be anything. At this point, we're talking your thermometer, your house, your smart thermometer. It's a meter that the utility company is using, all the way up to a Tesla car, all the way up to an oil refinery or rig out in the ocean. They're all they're all things that are serving some kind of purpose, collecting information, turning on and off, serviced by some maybe remote data center, but they're ultimately at the edge of what we're working with today in terms of technology and traditional architecture. They're the edge devices that live in the fringe. We're trying to figure out how do you bring those into the fold and make it one cohesive thought when you're talking about transactions related to IoT. This is a busy slide, so I'm sorry, but the takeaway here is that we're trying to unlock value. So everything from reducing the costs around operating the devices and increasing insights that come from those devices and the metrics they pull. We're trying to do that in a way that correlates it back to ultimately performance, because at Appdynamics, we're about making sure that technology is positively impacting your customers in whatever way that is, right? So when a customer interacts with you, whether it's by touching a screen in their car or pressing the up temperature in their house, that's an interaction. We want to be positive, and from our perspective, we want to make sure any part of the technology experience there is positive, and we're going to do our part to let you know if anything deviates or is negative experience based on the technology. So forgive me for that. So how do we derive value from these edge devices? Right now they're black boxes of data, right? They're turning off, they're turning on, next on the CD player, or on your iPod, or satellite radio. There's no direct business correlation. All the data that's there, when somebody touches that button, when something doesn't respond correctly, you want to know about that. But how do you know today? You don't. You might know because you see a drop in subscriptions, or you see less people interacting with that device. But you don't know exactly what's happening on that device to cause that drop, right? That's what we're trying to change. And these things cost money. Deploying these devices, there's pretty low margin. And so you want to make sure that if you're investing in your customer and supplying these things to your customer, you do it in a way that ultimately makes you money. So what we're trying to do with Appdynamics is correlate it from end to end. It's our mantra, and we're extending it further. How many of you are familiar with APM solutions? Okay, cool. So Appdynamics, Dynatrace, New Relic, a lot. We're APM, right? So what we try to do is monitor your technology landscape. But Appdynamics specifically, we try to do it in a way where we reflect the customer, right? So how is the customer interacting? How is ultimately the technology servicing it, whether it's multi-cloud, whether it's serverless, whether it's OpenShift, whatever you want to call it, or all of the above. It's a transaction traversing all of that. We want to make sure that all of those services are working in a way that ultimately provides a great service and end user experience. And now we're taking it a step further with IoT. For us, we simplify everything as a business transaction. A business transaction is our unit of measure that allows us to say, irregardless of everything that's happening behind the scenes, whether it's login in a traditional sense, whether it's login for our FSI customers, get account balance, make a transfer, check Forex rates, all of that. That's how we quantify everything, sum it up in concise ways to measure and react. But when you add IoT devices, these could change. You increase temperature, it could be for oil rig, I don't know, turn on a valve, turn off a valve, check temperature soil, or soil temperature if you're in agriculture. All these things help sum up all the services behind the scenes that help out. So call it the Tesla example. We have business transactions like connect, receive data, like maybe the head unit, a car at this point, maybe the car needs an update. They do that. A friend of mine who has a Tesla, when she bought it, they said there was all these reports of people being very uncomfortable because they came from automatic transmissions where the car would creep forward if you took your foot off the brake. So the next week, she got in her car, and there was a new update available with a tick box that said, enable creep, or something like that. And you tick this box, and now all of a sudden the car creeps when you take your foot off the brake. They push out these updates overnight, so your car is now just an extension of it's just a computer, probably more powerful than a lot of our computers at home, to be perfectly honest. But that's just another example of what a business transaction could be like this, for us, like process data request, process upgrade, complete it all. Summing up all those things behind the scene that ultimately make that possible. And we're taking it a step further, we're adding customer behavior, device behavior, network behavior. We're correlating that and presenting that all in one place and letting you go end to end. So in case there are issues, we can help you drive and find the underlying problem very quickly instead of having to do your triaging and up till 3 a.m., pointing fingers to somebody else, and ultimately somebody comes back to you and saying, that's your fault. Sure enough. So, trying to get rid of that. IoT is not new to the market, but what we can do with the data is, we can add that to our repository of all the metrics, the telemetry that's getting kicked out of everything that we consume by Appdynamics, and we add that IoT into the fray, and it just gives us one more dimension of data that we can say, how is that impacting your business, both on the business side and then on the customer side, the technology side. So I'm not going to bore you with screenshots, but I'm going to jump in, and now we're going to have some fun, and we're going to talk about really the differences between AWS and Appdynamics. It's a symbiotic relationship, and when I did some research on this to understand the Appdynamics play against the AWS play, it's pretty simple. AWS is focused on the device. AWS wants to secure the device, manage the device fleets, understand how they're connecting, give you some really fun functionality around saying, hey, you get this telemetry from a device, kick off a Lambda function or write it to a MongoDB. It's pretty much the easy button. When I think about how far technology has come, when I was playing around with this, I'm like, this is fascinating how much you can do with just AWS and allow you to do these things and connect these dots. So it connects the edge devices to the technology and allow you to utilize your own technology or your AWS investment. What we're doing is that correlation from end to end. We're focused on the customer, the device, the business value that we can derive from that device, and how it ultimately ties back to performance. If there's negative performance, we want to tell you immediately why, so you can figure it out and you can fix it. So before I jump in the demo, I want to kind of set the stage of what you're going to be seeing here. So I've got a little device. Give me 1 second. Put the mic down. It's going to be interactive for 2 seconds. So you got a Raspberry Pi. I need a volunteer. You, right? Below on that. Yeah. Yeah, hold it. You can hold it and just below on that blue piece for a few seconds. Okay. So I got this device that's communicating back with my laptop. Okay. Keep on it. No. I thought about it. I was telling my team, I was like, I walked by the tech company next door. I'm like, I should have bought the alcohol sensor, it's like the temperature sensor, the humidity sensor. And it's communicating. So that device is talking to my computer right now, which has 2 little servers kind of built up using Java, just on the back end, receiving the metrics from that device. What that looks like in reality is this. So you can see, as he's blown on it, the temperature is now at 24, which is probably not 24 in here, so that seems pretty accurate, and a humidity of 95. We guarantee the humidity in here is not 95, so that's pretty accurate, all right? So that's good. We'll hopefully see this, might actually be 25 in here, but as good. Thank you so much.
So your function is running inside Lambda, is it AWS?
No, this is just a local Java. I'm not doing anything creative with AWS for this demo. And then as this runs, the humidity will drop back down, but that's good. But what's happening in the background is 3 things. I'm pushing data to Appd as part of our IoT SDK to give us the business metrics and whatnot, and let's manage this device and get value out of it. I'm pushing it to AWS as well, and I'm also talking to the little servers inside to help you understand where we can correlate it all together. It'll all come together in a few moments, but that's the takeaway here. You can see the humidity starting to drop. The takeaway here is that I'm pushing to 3 different destinations here. So the first thing I want to show is in AWS. What does this look like? AWS IoT Core has some functionality around telling you the number of devices that have connected. When you build an IoT device, it gives you certificates, SSL certs, so you can encrypt the connections and whatnot. It's very, very powerful. Like I said, you can take it a step further. You can create a rule to say any of the payload data that's coming to me, I can kick off action. So I can push this stuff to DynamoDB. I can push it to a Kinesis stream, and you can do anything. Lambda functions as well. Everybody loves Lambda nowadays, so no, that's hot. And then what's cool is that I can also inspect the payload. So to make sure things are streaming into their respective servers, I've built, as part of the payload that's getting sent to AWS, is the temperature and humidity. So if all things go correctly, I should start seeing some streaming information. Yeah. So now, as it's taking sensor readings, it's pushing that up to AWS, and it's pushing it to a queue that we're watching live in real time here. And you can see the humidity's dropping as well. So kind of step 1, we've seen where AWS comes into play, and I can't go into all the detail, like drill into all the capability of AWS, but hope this is a little teaser of what it's capable of doing. On the Appdynamics side, what are we doing here? Well, we're getting some fun metrics out of this device, right? So I know how it's performing. I know the different values that are coming back, right? I'm sending as part of payload back to Appdynamics the temperature and humidity that this device is sensing. So you can see over the last hour, average humidity in here has been 77%. Average temperature has been 22. Each of these SRs is a sensor reading. So I'm using an SDK that Appdynamics has built that you just include as a Maven package in Java. And you kind of piggyback, you put together the payload and say, I'm going to add the temperature that I've sensed and the humidity I've sensed, and then I'm going to send a network request, which is essentially the push back to my tier 1 and tier 2, the servers called API gateway, and maybe some business logic behind the scenes. So that's what's happening here. Is I'm doing, the way I've done it is pretty much 1 to 5. Every 5 sensor readings ish, I push back a request to my backend. So if I look at what the devices if I look at device information, I have one device here. Its name is Koala, because I thought that was nice. Every device that you push back to Appdynamics is going to have a group, lets you manage these things, because in real world scenarios, there's not going to be one device. There's going to be, this is a demo environment of ours, but there's going to be thousands of devices. There's going to be tons of information streaming back to home base. But in my world, in this device that I've built, we've got this one device. And what it's doing, I'm collecting information around the device itself, and what it's doing is pushing back sensor readings as well as network requests. And those network requests is, like I said, it's a wrapper around the API call to push back the sensor reading back to the API gateway. So I'm going to drop this down to the last 5 minutes. And you can see here that I've now got information that every time a sensor reading happens, I push back, I guess my counter is off. I push back some information to my API. I know it's hard to see, don't worry about that. But what we're doing is we're monitoring now what's happening on this edge device. We're at the very far limits. Maybe something bad is happening. I've got a response time that you can see back over here, 1.6 seconds. Probably not the best when you're talking about a little IoT device pushing a small payload. So the question is, why is that response time so high? So to delve into that, I just drill back into the device and look at one of these network requests that's calling back, like I said, to home base. And I find one of them that has a snapshot. So the snapshot is what happens in Appdynamics when we figure out something's gone wrong, right? So we baseline everything. Baselining everything means that I know what normal is for every single metric that we collect, whether it's one core of a CPU in one of your servers up to the average response time for the overall application and everything in between. We know what normal is, so when things aren't normal, I can collect a diagnostic to help you drive into the underlying reason why. So in this case, we deviated, we spiked, something happened, we went non-normal, so we took a snapshot. It's like a red light camera. And in the snapshot, we've now jumped behind the scenes. So this device incurred slow response time. Now all of a sudden I'm seeing the 2 Java tiers that are running on my laptop that are supporting this, and I'm seeing the exact reasons why they're running slowly. So in this case, on the left-hand side, in the back it's probably hard to see, but I've got two calls out to 2 different web services supported by tier 2. One of them's handling something with the temperature, and one of them's handling something with the humidity. I know that's because I'm being told right there. There's the API for temperature, there's for humidity, and I can see the majority of time, almost 90% is being spent in humidity. So I can drill into that, and immediately it's going to take me to the line of code that's the problem. I'm not that creative, so I just put a nice sleep in here, and that's causing a nice response time delay. And ultimately, that's the end of it, right? So I've gone from now this device that my gentleman here, thank you for your help by the way, was holding and breathing into. Now we've gone to the back end and probably like 3 clicks, and we know exactly the cause of the problem to the line of code. We can see that drove over a 3-second sleep, so causing the issue. You can take this, the final thing I'll show you is you can take this one step further. All this information, that's very technically driven. All this information that we're ingesting into the system is all being recorded as events to us. We have a query language, ADQL, not very creatively named Appdynamics query language. And what it's doing is letting me query over this entire repository of business data and tech data that's coming back up to our controller. So all I've done here is say, show me all the temperature and all the humidity coming back from my smart thermometer. And it's just showing me all the ones that have come. And you can do all kinds of fun things. So if I want to say over the last, you can see top right, last 30 minutes, what's my average temperature? We've got the same functions that you would find in SQL or anything. I'll wrap this. And now I can see the average temperature. So remember, we're not in a business intelligence tool. We're not in any separate tool. We're all in Appdynamics. We've got the business side covered because this could easily be revenue. This could easily be a POS terminal telling you how many transactions have succeeded, how many have failed. And passing that level of information back. I just happened to do a temperature and humidity because that was relatively easy for me to comprehend. But just as easily could be a POS terminal that you're passing back that information and starting to carve out in some really fun ways. So I think I've blown through my time, but I hope that was helpful and helped you understand a little bit about what we're doing with the tool. Was that helpful? Cool. Any questions? Real quick? Okay.
Yeah, I got a question for the, you say your IoT connect to the, your cloud side, right?
Yeah.
Do you use security connection between them?
Between the device and...
Yeah, device and the cloud. So,
yeah, you can wrap it in the SSL certificate.
Because we found a problem that if you use security, you use WebSocket, you cannot identify, you cannot use MQTT protocol, right? Because I saw you use HTTP protocol just now. So in this case, you have problem, any device behind the firewall cannot connect out.
Let me talk about that afterwards, because
Okay.
I want to make sure I understand exactly.
Yeah, sure.
Cool. Go for it. What? No. Okay, good question. So the SDK is published by Appdynamics in Java and C++. All it's doing is wrapping APIs though. So we've actually got unofficial Node and .NET agents running as well. But you could just as easily wrap the APIs in JavaScript, whatever you want to do. Java is pretty heavy, I know, for an IoT device. I just did it because it's easy. I'm not good at JavaScript, so yeah, you can extend it however you like.
Do you support clientless mode without any installation of SDK?
So you have, well, look, there's two ways. The SDK is just a wrapper of public APIs. So if you want to go clientless and not install any Appdynamics APIs, or SDK, it's completely fine. You just use the published APIs and directly call the public APIs from Appdynamics.
Yeah, but do you have any kind of schema on the server side to understand all of these protocols from the devices? Right, so you understand what would it be transferring the topic to the service, you have to define like the schema, for that kind of specific binary parameters from a third-party device. There's no SDK.
Yeah, so you have to have access to the code in the third-party device, and then you select what values you want to pass back, and then you probably want to define a schema locally, so it's easy to just wrap those APIs and pass the values. It's up to you. Honestly, either way works just fine. But it's just the easy button, right? Because then you can just create an instance of a request builder, add an integer to it, and boom, it's inserted. You don't have to worry about the APIs you're hitting or anything like that. You tell it the URL at Appdynamics, you tell it your access key, which is essentially the password, and boom, you're off. I think for the sake of time, we'll probably save questions to the end or take. Oh, okay. Any others? No?
It's more around the Appdynamics engine component. Can I do on-prem or is it totally cloud?
Appdynamics as a whole can be on-prem. IoT for right now is SaaS only. But if it helps you feel better, we are SOC 2 certified in SaaS and are very, very familiar with the rigmarole behind making security teams happy and getting them comfortable with SaaS. So that is well documented for us.
How do you do the readiness for the new device in the cloud side?
How do you do what?
You got a new device, right? The device will connect to the server side.
Yeah.
So how do you do the identify authorization and authentication stuff?
Look, all you're doing with Appd is you're just passing information about the device itself and some telemetry or metrics that you deem valuable to understand whether it's. But to Appd, you're just hitting and posting information. It's not, you don't necessarily create a new device. The second it starts communicating, it shows up as a unique device in the controller.
Yeah, the controller needs to make the AWS IAM rule to.
Appdynamics is completely independent of AWS IoT, completely separate.
Okay.
Yeah, the AWS this app that I built leverages both the AWS SDK and the Appdynamics SDK. They're running in parallel.
Okay, you're going to.
Completely different. So you can do all your fun stuff with Lambda and whatnot with the AWS SDK, and then for us, it's collecting the metrics because for AWS, it's all about managing the device and all the devices out there, the thousands of them or the millions. For us, it's about managing the metrics and making sure that the underlying technology landscape that supports those devices is performing up to spec, and if not, helping you understand exactly why. Okay.
Is this dashboard is like a Visual Designer that you can pull in all sort of sensors and
Okay. I mean, for even some of these dashboards, like the one I configured, I wrote, I built this dashboard as you were talking earlier. I mean, you can just delete and add. I just did a metric that said, give me the humidity that my device is sending back, tell me the average, and does the rest for you. That's in lieu of doing the query language. The query language takes it a step further and lets you slice it and filter it in different ways. But again, you can take this much further in our demo environment where we have much smarter people than me building these things. You can really drill into some really creative knowledge. You know, some of the information, the metadata that's passed back includes device information like metadata, the firmware, not metadata, but like firmware, OS version, things like that. All in the hopes of you trying to figure out root cause when things go awry. So for this specific instance, you can see lots of errors by firmware, and it's very realistic that maybe you push out a new build of the software, right? And suddenly you see a drop in transactions or communications upstream. This would give you that visibility, straight away. So in this environment, we pushed out 2.0, and you can see the transaction amount and quantity dropped immediately. So this gives you that real-time visibility. We're not relying on logs. We're not relying on any sort of delay. This is happening as these transactions occur on the device. I did want to check. I was looking for something. No. Okay. You didn't load up long enough. I have an alert that if you keep it on too long, it gives me an email. Yeah. I should have done the breathalyzer. You would have won that one.
Can you show us the code that calls the SDK?
Sure. Do we have time? Jackson, I feel like I'm stealing time from people.
What was the question?
Can I? Oh, he asked if I control the code. I'm just rambling away up
Just
here.
showing the code.
Ramble away.
That the
Okay.
SDK call.
So yeah, the code, we have two pieces of code that implement the SDK. I have a code that sends back the sensor readings, and then I have code that wraps the API call and tells me information about the API call. So from the API call perspective, that's here. So I built just an old school HTTP request. I've set some headers. So what the headers do is allow us to build that front to back correlation to the back end. So because we have Java agents that sit there and monitor the performance of the Java, the JVM executing tier 1 and tier 2, they're monitoring the network stack of requests coming in and out. So what happens is I inject some headers onto the request, I grab the response, the agents see those headers, Appdynamics sees those headers on tier 1 and says, oh, this is a friend communicating. I'm gonna tell him who I am, give him some headers, and so then when we send back all the events related to this API call, I get back the headers that Appdynamics has already sent back as part of the API response, and that ties that knot together. So I tie those two bits at that point. It's a little tricky, but it's unbelievable how it works. It's really powerful. And then from the sensor reading side, it's right here. Sorry in the back, I don't know how to make IntelliJ bigger. Control-Shift-A.
Command plus.
While he's doing that, I will keep talking. So what's happening is I'm sending back another type of event. Does it need to be a presentation? Okay. I'm sending back just an event that says, I'm building an event. It's a sensor reading. There's a property that I'm adding that says temperature, which is my temperature. Well, it's broken now. Thanks, Jackson. Appreciate that. She did. And then I'm adding another property that's humidity. Cool. So I'm adding one property that's temperature, one property that's humidity. Again, this is the SDK handling all the hard work to build that payload. You can easily just call the API and pass this as probably a JSON file, and we consume it that way. So we're just doing the hard work here. I build it, and then after, hopefully, after 5 events, or after 5 sensings happen, I end up pushing out the actual event. So that's sending payload to Appd. That's that send event non-blocking, so it does an async call to Appd and uploads all that information. So you have control over how many network requests, how many API calls you're making. It doesn't just do it every single time something's done on the device. And these events can be creative, right? You can have application that the thing's turned on, a thing encountered a fault. I didn't even go into the error handling that we have, but it could be, you get into some of these really creative scenarios where the app turns on, request new firmware download starts, network requests happen to pull the firmware, and you can capture all that. So it just tells a whole entire story in the event log, as opposed to just what mine was, which was a sensor reading. Anything else? Okay. Well, thank you all for your time.
Hi everybody. My name is Sean Birrell. I'm one of the founders of a company called FluidIntel, which you've probably never heard of course, but we started out our business development product in 2005, I guess before IoT was really coined as a phrase, and we did some crazy things integrating sensors over serial, wireless networks and all sorts of things, but we're a baby with AWS, and I thought today, or hopefully it'll be interesting to talk a little bit about our journey. It's not going to be a technical talk, it's just more about actually a real world application and one of the first pilots we ran on AWS infrastructure. So hopefully you find it interesting. Like I said, it's not a technical talk, but it's a real world example of IoT and AWS cloud. So our mission is to protect the lifeblood of trillion-dollar industries. That's a very grand claim, but I'll sort of try to back that up. We predominantly monitor commodities. We monitor over $4 billion a year of fuel, for example, which is the lifeblood of a lot of our customers. Rail companies, mining companies. We monitor about 10% of the diesel fuel that would come into Australia. I'd say 6 of the top 7 world's largest mining companies use our solution to get fuel and lubricants into some of the most remote and harshest environments on Earth. And without those commodity inputs, their businesses stop. So we do play an important role in some very big businesses and a very big spend. Often it's their second largest operating expense after labour. And we're there to ensure that they get it to the right places at the right time and ensure they don't have it stolen, lost, or stock out. So FluidIntel. So we're FluidIntel, but not for much longer. Thanks to Intel Corporation, that sent us a letter about 2 weeks ago telling us that we have to change our name. So we riffed on Fluid Intelligence, and our product is DAPT. Fluid Intelligence is about adaptability. We did not think about Intel, the chip maker. But according to them, we're damaging their brand, according to the overly aggressive letter from their lawyers. It's a name we've had for quite a while. For them to only pick it up now, I kind of feel if Intel maybe focused a little bit more on what ARM were doing, we wouldn't be using so many Cortex M-series processors in IoT. But what do I know? So thanks Intel, we'll spend a lot of money rebranding pointlessly because they felt that we were damaging their brand. They did go after a charity called Yoga Inside, who did yoga with prisoners inside. So seriously guys. Anyway. Good to get targeted by a corporate bully. We'll change our name because we can't be bothered. So, and we're going to lose, right? So good on you, Intel. If there's anyone from Intel here, come and see me later. So we're the developers of Appdynamics. So it's the leading fuel and lubricant tracking system in mining and rail. Our customers are BHP Billiton, Rio Tinto, Glencore, Horizon. We've got deployments all around Australia, Indonesia, New Caledonia, Chile, Canada, and we're growing around the world. We've got a pretty comprehensive in-house R&D capacity for a small team. We do everything from PCB level design, firmware, all the way up to our enterprise web application with a range of technologies. We're currently monitoring about $4 billion in fuel and lubricants per annum That number might actually be a bit low. And we do that all around the world, like I said. But interestingly, we're expanding our platform into other use cases and commodities. So chemicals and agriculture are interesting solution domains for us. We are really specialised in making really rugged hardware and robust solutions that can operate anywhere. And that's a problem other industries have. So we really think we've got something to offer, and we're getting some really good traction there. And that's actually led us to Macquarie Bank, just so to make an investment. So they've made a strategic investment. We help them finance commodity supply chains already in some crazy locations, which I'll get into. And we've also already made an equity investment. So that's a really great backing for us after sort of 13 years of bootstrapping a business. We decided to take an investment, and that's really sort of leading to a really interesting second phase for us. So I'll talk a bit about our solution. So what is Adapt FMS? It's an end-to-end commodity supply chain monitoring and control. So lots of the stuff you hear around logistics, it's about containers or last mile, all of that kind of stuff. So tracking shipping crates and all that kind of stuff, and you know, you always see these like such and such raised $200 million to track shipping containers. There's lots of those kinds of businesses at the moment. It's a hot space. What we do is a bit different. We monitor bulk commodities. So we're monitoring fuel in a ship to port and then how it's transferred, or a chemical that's maybe going to a processing plant in bulk. So that's a little bit different than the packaged goods, and that's kind of where we focus on. We develop a full stack solution, so where there's not a solution in the marketplace, we'll build the sensor, we'll design the PCB, we'll write the firmware. Like I said, a lot of this was pre-IoT, which is a nice rod for our back now as we try to kind of migrate onto some new technologies. That's been is a real challenge for us and a real opportunity as well, but we do everything from that PCB design, industrial design, which I'll show you later, the firmware, web application, we do analytics, we're doing machine learning at the moment where, for example, we are monitoring very large fuel tanks, like up to 30 million litres, and we're using an ML algorithm to determine where measurement errors are coming from. So is it the calibration of the sensor? Is it calibration of the flow meter? Is it theft? Is it a leak? And we're using algorithms to try to determine where the source of those errors are. So that's really interesting work that we're doing at the moment. We've got, like, for example, some customers where we've got over 100 million records around the behaviour of a tank, and that's what the data set we're doing those analytics on. And our IT solution includes everything from sensors, gateways, field interfaces, and enterprise application, and we use both our own hardware and third-party hardware. So what that looks like in the real world is a customer might get, I'll use a real world example, BHP Billiton in the Pilbara. They get about 30 million litres of fuel every fortnight delivered by a tanker from Singapore. We monitor that, so I'll get out of the way. We monitor that fuel as it goes into their bulk storage tanks. Our solution then is used to plan all the load out. So they distribute that fuel via road and rail, about 2 million litres a day. We have a touchscreen controller in the fuel terminal where a driver will come up, there'll be a load plan there waiting for him, he will go and execute that load plan. Our controllers will batch the fuel in very precise quantities, like down to the litre. That then will be a pending load plan that we'll track as they go and transport that fuel for hundreds of kilometres out to all their satellite sites. So they have like 10 satellite sites spread throughout the Pilbara over hundreds and hundreds of kilometres. So we're tracking all those fuel distributions. And we're confirming those fuel distributions as they arrive on site. So what was planned and then what actually was delivered. At the same time, we're getting data in real time about inventories, so that data is being fed back into those load plans, so where and when they need fuel. Most of the time they have a fair amount of safety stock, but for example, we've got a customer in Chile at the moment. Incredibly enough, they've got half a day of survival time on some tanks, and they're sending a truck up a mountain pass every 30 minutes. So it's incredibly tight, mission critical application where they absolutely need to know where and when the fuel is being used, and they need to confirm that that fuel is delivered as planned. And then on the site, every single one of these devices is RFID tagged, and we will monitor all the fuel going down to John O's ute through to a Cat 797, which is a 300-tonne dump truck with an 8,000 litre tank. We're also monitoring all the lubricants, which is really interesting from an analytics perspective, where we're looking at lubricant usage, the performance of the vehicle, and it also can tell us things about preventative maintenance, things like that. So single site, and they've got 10 of them, we might be monitoring, say, 70,000 odd transactions a year, which is not a huge amount. These are big, high dollar value transactions. One of these trucks is worth about $4 million. They're going into expensive assets. They're running these service trucks. Those service trucks are about $4 million. We're doing analytics around their performance, the asset performance, flow rates, so how fast the fuel's going out, what's the filter condition, a whole bunch of different metrics around that, plus things like temperature. We can even use sensors to do things like count the particulates of the product as it goes into the tank and then check that it's within specifications. There's ISO standards as to how many particulates you can have of various sizes, various micron sizes. So we can collect a whole bunch of different data through that supply chain. That just depends upon control, and like I said, the RFID tag, and we also capture engine hours and things like that for burn rates and looking at cost allocations. So our solution architecture, we generally describe in 3 layers. So this bottom layer is the kind of, I guess what most people would understand is the IoT layer. So you've got lots of different measurement sensors, so flow meters, tank gauges of all different measurement technologies, whether that be pressure, radar, guided radar, ultrasonic. There's a whole different range of technologies used there. Product temperature, things like water level. I also said particulates. There's a range of different sensors. We try to be as agnostic to these as we can. There's very, very big vendors in this space like Honeywell and Emerson making very sophisticated sensors. However, we will make some sort of, some different sensors when we need to, but we try to be agnostic. The other layer here is the control layer. So we will do things like ramp the flow rate up of a pump. We will control that flow rate and then ramp it down if we say batch into an equipment item. So we do some real-time control as well. And then there's this authentication layer where we're RFIDing the equipment. We've made I just see this little Bluetooth low energy beacon there. We did hack one of those to do an early proof of concept, that exact one. I forgot what they're called, but I remember it well. So we've got our own Bluetooth low energy sensor that I can show you in a minute. And then we have our own touchscreen controller, which is like an iPad on like super steroids. It's like a 9 kilogram iPad, which I'll show you, which is machined out of solid billet of aluminium. It operates minus 40 to plus 80 degrees. It's got 6 millimeters of chemically toughened glass on it. It's a beast of a thing, so I'll show you that as well. And then at the top, we've got our web application, which predominantly, our customers are quite conservative, and we started this in 2005. There wasn't really an AWS offering like there was now, and so we've got a lot of on-prem. So a lot of really, really complicated customers with really sort of difficult environments to work in, I guess would be how to say. So that's our sort of solution architecture. So here's some of the hardware we make. So that's the DAP-MAC controller I was telling you about. So we've designed and developed that all in-house, all the industrial design. Every single one of the IOs is isolated to 2 kilovolts. It's got a whole bunch of different I/O on it, RS485, Serial 232, USB, Ethernet. It's got local backup. It's quite clever. I designed it, so I think it is. Like if you need to change out the compute module, you literally undo 4 bolts, unplug it, plug a new one in. It boots back up off a backup flash, and then off it goes. So it's all thermally coupled to the enclosure. So it's really designed for maintainability and uptime in super remote areas. Even to that extent, we designed our own UPS, which has a battery pack that can operate at 80 degrees C. These get onto service trucks. They do crazy things like arc weld onto a service truck without isolating it. We have all these insane situations. So that's, again, that weighs about 15 kilos. Again, it's all thermally coupled to the enclosure. All the IOs are octo-isolated. That switch, I don't think the doors on an Audi are engineered as well. Everything is like plug in, plug out. Anything, it's only passive components that are wired into. So if you need to change those LEDs, it's just a little module you plug in, plug out. If you need to change the power supply, you plug in and plug out. So again, it's that maintainability of the field. This is our flow computer that is measuring lots of sensors, pulse inputs, temperature. It's doing temperature compensation on the fly. It's controlling pumps, proportional valves. And this little IoT device we developed, it's a Bluetooth low energy sensor, like that. What it does is it beacons out the equipment ID. It also wakes up periodically, detects if the engine's running through vibration, and then records the engine hours. There's lots of different telemetry systems that you can read engine hours off, but most of the companies that do this are a nightmare to deal with. So we've just given them a kind of hacky workaround. Just stick this on the side, you get engine hours, you don't have to deal with Caterpillar or Komatsu. And so this has a 10-year battery life. And if you want horror stories, like ultra low power electronics that need to last a long line, we've got 4,000 of these in like jungles in Indonesia, and then you have to do a firmware upgrade over the air. Oh, it's exciting. Yeah, we had a really amazing incident where the order that you upgraded the firmware affected how some memory registers were written, which meant that one of the pins on the micro ended up floating high and reduced the battery life by a factor of 5. And these started just dying in the field, and it was terrifying. And but we got really good guys, and they worked it out, and we can do an over-the-air update. So we push down from our cloud solution to our DAP Mac. When they come to refuel, it detects the firmware version. There's a bootloader on there. It pushes the firmware down, updates the device, and off they go. It sounds really simple in theory. It just never works out that easy in Indonesia when it's raining for some reason. And we built a web application. So this was an example, like the tank telemetry data. We're monitoring thousands of tanks around the world. We're capturing all that transaction data. We're pushing into the cloud. We're doing a lot of analytics at the moment. So we're doing things like, how is this service truck performing per shift? What's the throughput? Is it operating in an efficient way? Lots of different things. We've got about 30 different analytics modules in our roadmap at the moment, and it's quite interesting. So that's our kind of solution, and it's on-prem, and so that's challenging for a small team. And I'll go through some of the challenges about moving to cloud and why we wanted to move to cloud. A lot of this is probably pretty obvious, but I apologise, but it's our experience. I just thought I'd share it with you. So we got a lot of on-prem Windows environments and SQL Server DBs. So being the genius I am, I decided that we'd build our application in Ruby on Rails, and our first customer's like, yeah, no worries, you can deploy that on a Linux server. Yeah, MySQL, no problem. That's the only customer that's ever given us that environment. Every single customer since then has been a Windows environment and a SQL Server DB, which is not ideal for a Ruby on Rails application. So nothing wrong with the environment, it's just that our tech stack is not really a first-class citizen on Windows. So that's a real problem, and it's getting worse. It's getting worse, so that's fun. But we do run successfully a Rails app on Windows with SQL Server. So yeah, you can give our devs a pat on the back for that. Well done. Huge variation of standard operating environments. Just bizarre. Like, we'll get Windows environments just missing like critical services, and then you got to go and deal with their IT department, and then that's a 2-month approval process to get their SOE changed, so it includes some service that we need. That's always fun. Our field devices rely on wireless comms outside of cellular coverage, so we're in really remote areas. We're often on their mesh networks. They've got very sophisticated mesh networks now. When we first started, we were literally putting serial telemetry radios all over mine sites, clamp aerials, running these things everywhere. That's great, but they don't really want to open those networks to SaaS services because some of our hardware is on a process control network, which is absolutely mission critical to the operation of their site. I would argue that's poor architecture, but often that's how we end up. So we end up with some of our hardware on probably the most critical network on a mine site, and understandably, they don't really want to open that up to a SaaS offering, as is, I guess, commonly understood. I think you can all imagine some of the workarounds that we approach with them. The non-technical kind of things were, our customers lag on upgrades because they've got these Byzantine upgrade processes where apparently users are stupid and you need to train them about the smallest possible change, and therefore they're worried about any sort of program where they're being upgraded outside of their normal change management process, and they've got real concerns around that. It is a pretty critical software system, but I think that's probably overstated in terms of how big the changes are and how risky they are to users, but they are worried about being constantly upgraded through some sort of SaaS offering, which again we deal with. It's a critical application deployed in very remote areas. They have a sense of, if we control the network and we control the infrastructure, that is some form of risk mitigation for us. So they're giving up a lot, allowing us to maybe move these into the cloud. And also, because they don't want us in their process control network, us providing the network on site. They're large conservative customers, so they have a lot of power. We're a small business, they're very, very large enterprises, and kind of what they say goes to a certain extent. And interestingly, a lot of our customers zigged away from cloud when everybody zagged. And the kind of reason for that is they had some really poor experiences, and particularly around access to data. Our customers build enormous data lakes. They're doing a huge amount of analytics, and they're having absolute stand-up legal battles with, for example, the vendors of the electric drives on their big trucks, and who owns that data, and what they can do with it, and all sorts of things. So they didn't want yet another vendor that had some sort of, control over their data and wasn't going to let us access it. So we've sort of addressed these things just with a kind of commercial perspective, because we think it's a win-win going to Amazon and utilising some of the technologies that are available. But also the other challenge is we're a small team. So we're supporting, I think, about 19 different environments at the moment, which is not fun. And we really think for our customers that, well, that's weird, that the opportunities, it is a win-win going to cloud. So we get a standardized environment, which is helpful for us, a bit of a no-brainer. We get to use a better supported application server and database. We get to go to Linux, we get to use MySQL, and kind of all the first-class citizens in the Rails environment. We get to improve support for users in enterprise. I cannot believe the low level of support some of the enterprises put up with. We've got a customer at the moment that has had consistent database connection issues for a month. We would never let that happen. But if you look at their kind of order priorities, it's kind of like their ERP system, SAP, then it's probably some sort of control, system control, process control thing, then it's probably site security access, and we slow that down. And so we care enormously about uptime, but some of the IT service providers for their customers don't care about our uptime nearly as much as we do. So we think we can actually offer better service. Also surprisingly, to me at least, I thought they'd have this nailed, but improve security. Because they need to get this data, for example, to their vendors of fuel so they can plan deliveries, often people do these dodgy backdoors. So they'll have these like reverse proxy servers that are just open to the web and people can log in, which is absolutely against every single policy they have. We tell them that they've got it, people turn a blind eye. We wouldn't allow that. We can actually lock it down for them all. So that's something we can do. If we don't have to do those things and support all these environments, we can actually focus on development instead of the ops and support that supporting so many different environments is. And the other thing is integrating third-party services. So there's a bunch of geolocation services that are much, much easier if we can sort of be on AWS and sort of integrate with those via the sort of standard APIs, rather than trying to get some sort of on-prem version, update that, keep it updated, all those kinds of things. So we ran a pilot. So this was our principles to do it. We don't get many chances to run pilots. It's pretty mission critical. So we got one. And so we wanted to try to do it right the first time. First impressions really count for this. If we whiffed on this, it was going to be bad. But we started developing this solution a long time ago with an on-prem architecture. So there was some legacy issues with connecting some of our field devices, and we had to VPN into them, which was a nice complication. We thought it important to pick a ludicrously remote location in a different time zone, because these things are too easy and you need to add a degree of difficulty, and I think we really nailed that part. You'll see in a minute. We wanted to do infrastructure as code. My personal instinct is to go and spin up an EC2 instance and hope for the best. Fortunately, there's people in our business a bit wiser than that, and they said, no, we need to do this right from the first time. This isn't something we're just going to go and set up one-off. We're going to do infrastructure as code. We're going to manage it all, and that's where we got Polar 7 to really help us out and architect it correctly from the get-go. And because we spin up separate infrastructure for a whole bunch of reasons for our customers, we're not constantly deploying sort of, CI/CD was kind of a phase 2 for us. That wasn't a real focus. Well, that's interesting. So doing it right the first time, you're not going to be able to see this, but instead of just spinning up an EC2 instance and hoping for the best, we tried to do it right with Polar 7. We made sure we had multiple availability zones, we had the load balancers set up, we had all of our VPNs set up correctly, we did it all as, like I said, infrastructure as code. We really did try to do it right the first time. So this is a big investment to make for a small pilot, but because of, as you'll see, the location and the kind of high stakes, we felt the way to do it. We had to use a VPN to overcome some legacy issues. So this is on site. It's actually a little bit out of date, but it's good enough for now. This down here is we're monitoring some tanks at a coastal location. I won't reveal it until a minute. We then had to connect those via serial to a modem, which then wirelessly transmitted to literally a mountaintop, which we had to fly up in a helicopter when the weather allowed us to put the other node. We then put a consumer grade, essentially, netgate there for a whole bunch of compatibility reasons around OpenVPN. That then did, I think it was a microwave backhaul back down to the camp, which then went through their satellite connection and then to our AWS infrastructure. So we had this whole deploy a serial node point-to-point network out in the middle of nowhere with a really small window to do it in, and have the VPN work through that to some legacy hardware down here. So that was complicated. Then what we want to do, this is really messing up here. We went to, that says pick a location in a ludicrously remote area in a different time zone. So what we picked was Hope Bay in Canada, the Arctic Circle somewhere down there, that's Greenland. It is very remote. They can get fuel in this tiny window every year. We got the order to do this job like weeks before that fuel was to arrive. And the whole business case was that Macquarie Bank was going to, as soon as the fuel arrived, buy that inventory based on the data that we sensed, and then own those molecules and then sell it back to them every 2 weeks. And we had a very, very small window to make this work. And it absolutely had to work because we were also in due diligence with Macquarie Bank to invest in us at the same time. So that added a real... So I think we really nailed that requirement, which is to pick a ludicrously remote location. Could not have done better. Proud of the team. So the other part was to do infrastructure as code, so that was really important to mitigate risks. So I said this is high stakes deployment. We make a mistake, it's going to hurt. We had to set the expectations internally about how we're going to manage infrastructure of this type. You know, we wanted to get out on the right foot, not kind of set ourselves up for some sort of poor practices. It was done in the right way from the start. And we had to increase our customer comfort about, we had a robust approach that if the infrastructure went down, we could redeploy quickly. It was robust, it was repeatable. So that was kind of the part of that. So the key considerations for us were to avoid a single point of failure. So with this business been around for 15 years, I have never ever had a physical damage to a tank gauge. And I think about 2 weeks before Christmas, they somehow on top of a tank which is about 12 meters high managed to snap the head off it. Unbelievable. Try getting a fuel gauge, a level gauge 2 weeks before Christmas into the Arctic Circle. It is difficult. So we had anticipated lots of other failures. We had multiple gateways, we had all this kind of stuff. We did not anticipate that, and these are custom probes, they're difficult to get, so that was interesting. Keeping spares on site, again these aren't relevant to everybody obviously, but this is kind of what we had to do. We had to keep spares on site. There's 2 charter flights a week. You cannot get, and they're cancelled often during the winter, you cannot get things in there. You have to configure things in-house and prepare for things to be DOA. We couldn't get enough netgate routers, so we just shipped one. It arrived, we fully tested it, configured it in the office. It arrived at Hope Bay, it was dead. And so I bought one, I can't remember where, some weird place, got on a plane, flew to Edmonton, was ready to get the charter flight to hand deliver a $600 netgate, like the most ridiculous thing in the world. And then fortunately the fuel couldn't arrive because the icebergs didn't blow away. So, but like the most sort of, you know, those things. We couldn't get 2 netgates, so we just shipped one, and of course what thing dies? What thing goes DOA? The one thing we didn't have redundancy. It was just crazy. The challenges of extreme remoteness in different time zones. So you're trying to help a guy troubleshoot a VPN connection who's up on a mountain with no mobile reception. So he writes notes, then he flies back down, and then he tries to call you, and it's like 2 a.m. and you try to exchange some notes and then give him something to troubleshoot the next day, and then off he goes. It's like, it is really sort of asynchronous, difficult, challenging environment to troubleshoot. So a great one for a pilot, first one for AWS. And then the robustness of the VPN, so we were really concerned about this because the comms are going up and down, and you read all these horror stories, the VPN's not recovering, and we even saw that in the office. It's been bulletproof. That's actually been the least of our problems, is the VPN tunnel to our legacy devices. So there you go. So we were successful in that. So the next steps for us, this has been running for about 9 months now. So now we're working on a sort of code build, code deploy pipeline to automate our deployments. We're really eager to try TimeStream. We can collect a lot of time series data. We've signed up for the TimeStream trial, but we can't get in. So if anyone's for AWS, can get us a bit of an invite. Come and talk to me. We'd love to try. We plan to migrate to IoT Core, sort of MQTT-like functionality there. It takes a lot of things away from us, but more so probably device management. Managing all of that ourselves is a challenge, and it's a lot of work. So there's lots of nice stuff out of the box that we can utilise in that part of the AWS offering. And also, AWS gives us the ability to utilise some of their technologies. We're approaching some things that we have to apply lambdas and things like that, where we can split up what is a fairly monolithic application at the moment to a lot more services, which helps us as we go into some of these new market verticals where we're wanting to probably recombine a bunch of services for maybe a slightly different use case, so chemicals or what have you. So we're excited about that. So that's our next steps in this journey. I thought I'd just give you a couple of photos. So this is Phil, one of our guys. This is when he had to fly up to put the aerial up on top of this bad boy, which is up on top of the mountain, which sees down to the port. This then backhauls to the camp, where it then goes satellite into the AWS. This is what happens when you get a probe that's 2 meters too long for the tank, and we had to make a spool to extend out the tank so we could hang it so it didn't bottom out on the bottom. The probe's a long kind of tube that runs down, and the compliance plate that they took a photo of misstated the height of the tank, so we ordered the wrong size, and these things have like a 2-month lead time. So, but they're pretty self-sufficient up there, so we made a giant spool that's stuck on there. So the sensor should be right on the top there, but it's now 8 feet in the air, which I think is kind of hilarious. And there's some of the other tanks that we're monitoring. So this was obviously in the summer. And yeah, so I just thought it's kind of cool. So yeah, look, it's some of the things are obvious, but it's just a real-world example of where we kind of, managed to run a pilot in AWS, managed to make it work, but also we see huge benefits in being able to kind of leverage off a lot of the technologies you can get out of the box, and we're excited about that in the future. And we'll continue to sort of encourage our customers to adopt this sort of cloud offering, kind of being the hybrid cloud offering, and hopefully we grow more into AWS from on-prem from there. And the final thing is we're hiring. So we're out at McMahon's Point there. If you want to join these friendly people, we're hiring in head of engineering, product managers, back-end, particularly if you're Ruby on Rails, even embedded. So we've got quite a few roles open, so if you want, email us with your interest at people@fluidintel.com. We'd love to hear from you. We think we do some pretty interesting work. Nobody really knows us, but I think we do, to do PCB level stuff all the way through to an enterprise web application is kind of cool, and you get to work all through that solution stack, and we'd love to have you. So yeah, I hope that was interesting. Thanks. Any questions? Yeah, I hate to, and I avoided dropping anything about blockchain in here because I didn't want to get things thrown at me. But yes, that is actually, we feel those kinds of things are actually interesting, because what we want to do is be the sensors that write straight to chain. So a lot of the solutions you'll see still rely on traditional transaction settlement, which actually still relies on paperwork at some level. And we feel that, really closing out that loop, kind of like down to the molecule, that's really where we can come in and we can help that. And you've always got that garbage in, garbage out kind of problem. And yeah, we're very keen to kind of look at those smart contracts where they can execute on delivery of the fuel. One of our customers kind of already does that. They were settling their payments on 28-day terms. What we did was we sensed the deliveries, we checked against the docket. If it was in a tolerance, it triggered in SAP a payment process, and then they get like a $4 million a year early payment rebate. It's kind of a crude version of that, but yeah, we're really interested in that kind of application, for sure. Sorry.
Because your networks are very remote parts of the world, and it probably could potentially drop out, does that mean that you have to have a store and forward type of capability for transactions which are being processed and then have to be forwarded to?
Yeah, absolutely. So, I mean, when we first started, it was like serial networks. It was like high latency, low bandwidth, and huge outages. Like that's just our standard operating environment. So, yeah, we've always had to buffer transactions. We always had to push those up, you know, when we can.
I'm just interested because you put your sensor globally. So you put your AWS in several regions or just one region to centralize?
Yeah, good question. Because of our customer requirements, and I mean, this is a pretty high value solution. We don't have sort of any multi-tenancy architecture. We're standing up instances for each of our customers where they want it. So that one I think is in Portland. So yeah, it's just where the customer needs it and where it makes sense. Yeah.
I was intrigued about the control you had with like the IoT of the trucks and stuff.
Yep.
You're saying you're running like analysis of the whole, how to improve the actions, you know, things like can you monitor like tire pressure there?
So there's a lot of solutions around the telemetry space. What we try to do is come in and provide more accurate data than perhaps some of the telemetry solutions can provide. So I'll give you an example. So fuel burn is generally calculated by counting injector pulses at the engine, multiplying that by a volume, and then working out what the fuel burn is. But if your injector is dirty or there's any other kind of performance inhibitor on there, your fuel burn can be out by a lot, 20%. What we do is we monitor every litre that goes to that equipment item. So we give you the logbook method to compare that. So we kind of feel that we kind of sit next to sort of some of the telemetry solutions that are monitoring tyre pressure and all of that. We can help normalise that data. Another one would be like lubricant top-ups. They go and do a huge amount of lab analysis on particulates in lubricants, but if you don't know how frequently that sample is being topped up, you don't know how diluted it is. So you don't know if, so a lot of them don't actually trust. They do all the labs because they have to, but then don't trust the results. So what we do is give them the top-up data so you can normalise that sample. So where we kind of try to stick to our knitting a little bit in that really just focusing on the areas where we've got a special piece of data that can kind of add value to some of those other systems. Yeah, that's kind of the idea, I guess, yeah. Sorry, yeah.
Scenarios that involve a large number of IoT devices, do you use any kind of tooling to do qualification of
We're really quite weak in that area. We're not a large number of devices actually, really. When you look at some sort of some of the IoT deployments, you know, where they're doing say smart metering and it's in the millions. So we've kind of got away with it. But no, we know that that's something we need to improve. Like we've got 4,000 of those Bluetooth low energy sensors. We need to do better device management. That's definitely something we need to improve on. And we are focused on those UPS batteries. When you run a battery on the side of a service truck, it will get up to 70 degrees and it degrades those batteries fast. And so we need to monitor the battery health. That's actually not a straightforward thing. If anyone's owned a laptop or a phone, you know how much they lie, like those battery gauges, they're just terrible. Well, that's kind of mission critical to us, like, you know, because all of a sudden it won't gracefully shut down, we corrupt data and it's a disaster. So we're actually solving that at a hardware level. There's some interesting new chips there that help us with battery condition monitoring. But yeah, it's definitely something we need to improve. Well, thank you for listening.